Okay, so guys, when we take a look at pH, basically all pH is a way of looking at how acidic a substance is. That's really all it does. It's going to give us the relative value of how acidic something is. So that's what I want you guys to write down. So basic pH is just how acidic something is. And we split these into basically acids and bases. The image I have up here is called the alkaline, or the alkalines. Remember, we talked about that yesterday and the day before with that group on the periodic table, the group 2. So a lot of your substances that have magnesium or beryllium, those types of things, that is basically going to be alkaline substances. So together we often will call these bases. So you have acids and you have bases. Your pH scale goes from 0 to 14, with 7 being the neutral zone. Pure water, pure distilled water should be at 7. Should be. And then we have a whole range of things. That's what we're going to do today. I want you guys to go around, because there's some really surprising things that you would never guess about where things actually line up on the pH scale. Kind of weird. So one thing that's important, we talk about, well, what makes something an acid, what makes something a base? One of the things I will tell you guys right off the bat, acids typically will have the H+ ion. Okay, it's some kind of dissolved solid where you have a hydrogen ion that's kind of floating out there and makes it acidic. Think about, and this is one that's very commonly used in earth science, hydrochloric acid, HCl, has a hydrogen ion attached to it. That's what makes it an acid. If you guys get to chemistry, you'll probably at some point deal with H2SO4, which is sulfuric acid, or HF, which is far more worse than sulfuric. That's fluoric acid, So this stuff's pretty crazy. And in fact, hydrofluoric acid is so corrosive, it's very difficult to find a container that it will not actually eat through. It's a very, very potent acid. But one thing I want you to know is that all of these have the hydrogen ion that's attached to it. Your bases, on the other hand, tend to have the peroxide ion, the OH ion. Okay. So remember yesterday we dealt with sodium hydroxide, so NaOH. So that solution you guys created yesterday is actually going to be a alkaline type of solution. It's going to have a very basic or a high pH level. Alright, so those are some basic things to remember. Now, I'm definitely telling you, remember in the lab, we don't play around with things, we don't try to drink things that we don't know what they are. But just for future reference, we are not going to be taste testing any other items on this counter, no matter what it says is in there, we don't taste them. But your acids will taste sour, and they're very corrosive to metals. And those are some of the key characteristics you want to remember. Acids are sour, and they corrode metals. And on the other hand, your bases tend to have a very bitter taste to them. Bitter versus sour. Something about sour like lemon. Bitter like, I have no idea. Trying to be something. I don't know why it's so much fun. She actually did what I said here. Now, so we're talking a little bit about pH again. So the higher the pH level, the more basic the substance is. The lower the pH level, the more acidic it is. Okay? So that's just something to keep in mind when we're talking about pH scale.